This presentation discusses the course project prediction of the electrical energy output of a combined cycle power plant. This is the data that's provided is structured data, which consists of observations, instances, 4 features, and of course 1 target. Data has been split as follows. Almost 16% of the total available data has been assigned to test data, which is 1528 instances. There's been some semi-random selection for validation as well, and the validation data is 1340 instances, which is 14% of the data sets. That is a training data of 6,700 instances, 70% of our data set. This will be supervised learning, with the learning task being regression. The question was, do we include all 4 features? Now, there's some strong correlation between temperature and pressure and V and PE. Between the AP, atmospheric pressure, and relative humidity, the correlation is not as strong, but the visualization denotes some level of importance. This was decided to be tested using 3 different models to see the impact. Model 1 would use all features, and Model 2 and Model 3 will exclude the atmospheric pressure and relative humidity, respectively. This is following the model of selecting features, choosing algorithms, setting hyperparameters, train model, and evaluating the model. As mentioned, we're using Excel and using regression analysis. We're looking at the correlation and the R-square parameters as means of testing. So running the test data through the 3 different models, again, Model 1 including all features, and Model 2 excluding AP, and Model 3 excluding RH. We can see that the better performing model is Model 1, including all features expected, albeit only marginally better. Nonetheless, the decision is to use all features for the further analysis. A manual split of the data has taken place in order to use k-fold cross-validation, and because the data is nicely split between validation and total training data, we're going to be using 5 folds as per the visual example here on the screen. Each iteration has been then validated with a validation set, and the best performing model has been on the iteration 4. So this is the selected model. Again, regression model in Excel with iteration 4 as a model, using the test data. So the forecasting results on the test data gave us a correlation and the new R-squared value. Now, again, this is actually better performing versus the previous Model 1, which was without the k-fold regression modeling. However, again, this is a marginal improvement. Nonetheless, the final model coefficients now are as follows in this table. There's been some other work, preliminary for future work to be carried on here. The data has been put through Google's AutoML training. And this has actually provided some marginal improvements again. You can see the R squared now is 0.958, a little bit higher. Effectively, this highlights that indeed further work can improve the model performance even more. And if we go back into investigating and clear the data from some potential outliers, the garbage in, that have been visibly on the visualization plots, coupled with the AutoML training approach, potentially further increase the model accuracy.